Hello and welcome to the demo of our MLOps pipeline. In this demo, we use the open wine quality data that includes two datasets, a red wine and a white wine dataset. Each dataset contains 11 input variables, which are some chemical attributes, and one output variable, which is a wine quality score. In this demo, you will see two types of models, one for predicting red wine quality and another for predicting white wine quality. All models used in this demo are simple sklearn elastic net models. So we have already deployed all the pipeline components to a local Kubernetes cluster beforehand. And as you can see here, we also uploaded the KFP pipeline used in training to the MinIO storage service in advance. So this KFP pipeline will be used to retrain both the red and white wine models. And as for the pipeline configuration, the monitoring is configured in such a way that we monitor data drift and predictions mean absolute error. The configuration is written by using the query language by Prometheus, like this one. So this expression means that for each model, if Prometheus detects the mean absolute error is larger than 0.3 and data drift occurs, then an alert will be pending. If such a large mean absolute error and the occurrence of data drift lasts for at least 30 seconds, then an alert will be sent to trigger a retraining round. As for the A/B testing, the same service level objective and reward metric are used in A/B testing both the red and white wine models. The service level objective requires that the 95th percentile response latency of the inference service should be smaller than 5 seconds. And regarding the reward metric, the smaller mean absolute error, the better the model performance. The progressive traffic split method is used in A/B testing. So this means that if both the old and retrained models satisfy the service level objective, then traffic will be shifted to the model with a smaller mean absolute error. The shifting ratio of traffic will be decided by iterate using its traffic splitting algorithms, and each A/B testing consists of 3 iterations, and each iteration lasts 2 minutes. And now, as we can see from the dashboards, a red and a white wine model are already running in Kserve. And this figure can describe the progress of the demo. So at this moment, we are in this stage 1. So there are two models, like two initial models running in Kserve. The red wine model was trained using white wine data, and the white wine model was trained using red wine data. So in other words, we intentionally trained these two models using like the wrong color data, so their performance will drop when they receive the correct color data. And now we start sending like red wine data to the red wine model and white wine data to the white wine model. And the ground truth will be sent with like 10-second latency. And the sending rate is 1 request per second. Now, like after a few minutes, we can see that Prometheus has detected that for both models, the mean absolute error is larger than 0.3 and data drift occurs. So 2 alerts, one for each model, has been triggered. And these 2 alerts will be sent to trigger a retraining round, like to trigger 2 retraining rounds in Kubeflow pipelines. And then now from the dashboards, we can see that 2 retraining rounds, one for each model, are started. And by clicking the Kubeflow running ID, we can like we can see how the corresponding retraining kubeflow pipeline running is progressing. So now here we can see that the retraining is completed, and we go back to the dashboards. Here by clicking the model version, we are in the MLflow UI, and in this MLflow UI, we can see like some more information of the retrained models, such as the name of the K-serve inference service where the model is running, as well as the training data used in the retraining. And we can also see like the parameters using model retraining and the evaluation metrics. So if we go back to the to this figure that describes the demo progress, at this moment we are in stage 2, where we have 2 models for red wine prediction and 2 models for white wine prediction. And now we start sending red wine data to both the red wine models and white wine models. And as we can see again from the dashboards now, A/B testing for both the red wine models and for both the red wine and white wine models are started. So now we look at this figure again. So as we remember that the old red wine model was trained using the white wine data, and the new red wine model was trained using the red wine data. On the other hand, the old white wine model was trained using the red wine data, and the new white wine model was trained using the white wine data, because now we are sending red wine data to all of the models. Then we can expect that this new red wine model will be better than its predecessor. However, the old white wine model will outperform the new one. Now, if we try to check the changes of the ingress rule, for example, for the white wine model, then like when the retrained new models are deployed in the first place, the traffic split was like 50 and 50. So 50% of the user traffic will go to the old models, and another 50% of the traffic will go to the new models. So as the A/B testing is progressing, then at some point we can see that now for the white wine models, the old white wine model is receiving 95% of the user traffic, while the new white wine model is only receiving like 5%, because the old one is better than the new one. And then finally, as the A/B testing is completed, we can check the results. So for example, here for the red wine model, the new is better than the old. And so here like we can see that the winner is the new version, which is this version 2. And again, for the white wine model, here we can see that the winner version is the old one, which is this version 1. And so now if we go to the Grafana, then we can see that like for the red wine prediction, the arrow was kind of large in the beginning because of the data drift. So like the arrow was larger than the 0.3 threshold. Then after the retraining and A/B testing, the performance of the red wine prediction is becoming better.